Another thing that we discussed back in chapter 3 is we talked about our empirical rule. So remember, our empirical rule is a rough guideline for the approximate percentage of data between 1 to 3 standard deviations of our mean. Right? So the empirical rule says that if the distribution is unimodal and symmetric, or normal, as we're going to start to call them, then approximately 68% of the observations will be within 1 standard deviation of the mean. Approximately 95% of the observations are within 2 standard deviations of the mean. Nearly all, or 99.7% of the data, is within 3 standard deviations of the mean. We also generally consider values to be unusual if they are further than 2 standard deviations away from the mean. So these images are ones that we saw before. Right? So within 1 standard deviation of the mean is 68%. Within 2 standard deviations of the mean is 95%. And then anything that lands out in these little tails, right, those are unusual values. And those unusual values are within 3, well, not necessarily always within 3 standard deviations of the mean, but they're within those tails that are outside of our 2 standard deviations of our mean. Okay, so according to the empirical rule, what percent of z-scores are between -1 and +1? Well, z-scores compare to our standard deviations. So between -1 and +1 standard deviations, we have 68% of our z-scores are going to be within those values. Right? Within 2 standard deviations, we have 95%. Within 3 standard deviations, we have our 99.7%, which is almost all. Right, so now to kind of connect this to where we started, right, we're thinking about continuous probability distributions, right? And when we're thinking about continuous probability distributions, again, we're thinking about area under a curve, right? This percent that we're looking at is the area under the curve. Right? So if we were to look back up at this image over here, just for instance, this darker shaded area in the middle, that's within 1 standard deviation. That's 68%. And if our area under our total curve is 100%, we have 68% in the shaded area in the middle. As we move out, well, now we have 95% in this shaded area in the middle, and then we go all the way out to 99.7% in that shaded area. Right, roughly what percent of z-scores are between 1 and 2? If we go up here, here's within 1 standard deviation, here's within 2. We see 13.5% in that little piece right there. So our answer to D is going to be 13.5%. And then our answer to E, roughly what percent of z-scores are greater than 0? Well, 0 is our mean. Our mean is in the middle. So that means that 50% should be below, 50% should be above. So our answer to this final one is going to be 50%. Right, so our idea of our empirical rule is going to and does directly relate to finding area under a curve. The only difference is instead of just focusing on nice even standard deviations like 1, 2, 3, -1, -2, -3, right? What happens if we have a z-score of 1.7? Right? What happens if we have a z-score that's not one of those nice standard deviations? Right? We still want to be able to calculate our area, and that's where we're going to be heading to in our next set of problems.